Hi everyone, welcome back. In this video I will talk about least square and least square estimator very simply, and also I wanna talk about why it is important, why we use it, where we use it. I will talk also about them. And in the next video, this will be two video series. In the next one I will talk about the usage of it in C++ side. I will implement it and I'll also share that code in GitHub. But this video is also very important as the first step. And let's continue on this one. Since I wanna really explain it very clearly, very simply, let's talk about this one first of all. If we get this kind of two equation and two unknown, we very simply solve it and we get x as 7 and y as 3. But this is a scenario in the world, and what if we get two unknowns but many equations? What happens in this scenario? You can say that we just take two of them and we find the solution. Okay, this is a maybe this is a way, but not a good way. Why? Because you have also other experiments. This can be many, can be continue, and if you just get two experiment, you just consider two of that time, but you don't consider the rest. Maybe those two experiment not really valuable, so it's very important to use at all. But how you will use it? In this also kind of system we call our determined system. This one was a determined system, this is over determined, and if the unknown number is less than the experiments, is undetermined system, and this one over determined system. But in this case we of course need to find these unknowns x and y. But how we find it? In this kind of problems we mostly use least square estimator, which is very useful, and that's why we use also a least square estimator to determine the unknowns in over determined system. Okay, this is an example of overdetermined system. You can think of these every dot as an experiment, and x and y axis are the properties of these all data. These can be anything. For example, you can think x line as a meter, this one is time, let's say second, and this can be velocity of any object. For example, you can think, or you can think these are let's say for example fish. You are measuring fish length and width. These are can be x line can be length of the fish, and y line can be the y axis can be the width of the fish. So you have many experiments, but you need to get a optimal line. And how you will get that optimal line? Also, as I said, this can be also 3D. For example, we are considering now this is 2D. You can add one more axis to this, and you can again this same method will work in that one. As I said, in this kind of distributions, many experiments, but you just need some coefficients. Then you need to use least square, and least square will help you to draw this optimal line between inside this complicated distribution, and this line will help you much. Also, maybe to understand more simply, you can think of maybe think all of these dots as a human, and think this line as a rope, and these all people are pulling to each other. They are also in the same strength, and they are pulling this rope to themselves, and then you get this as a stable line. For example, you can also imagine in your mind like this. This is just a example to distribution, and how least square estimation need to be used in this one. Okay, what this equation? What this is also this is an equation of the least square estimator actually, and I just put this directly. But what it seems actually, let me show you. This one, it comes from here. This is no different, by the way, from, for example, you have an equation like this, right? And this is no different. This is totally same. Just when you want to use least square estimation, you need to deal with some linear algebraic equations. So that's why this seems little complicated. also the proof of this. Some people, because dedicated, wanna see how we get this, and this is also explanation how we get this, but there is no need to invent the wheel again. It's already done. Just take this and use. No need to, in my mind, I think like that. We don't need to deal much with the background actually. And okay, this one we will use, but what these things mean, I will talk all of them simply after you get after we did the example how we solve this. You will very easily understand what does it mean. So just, but you need to use this equation. Also you will understand what is x, what is y, and how we use it, and there will be no problem. Maybe before passing this one, I need to also suggest you this one. In here, I have a GitHub repo which inside have many some linear algebra big calculations very easily. For example, getting cofactor, determinant, and adjoint, inverse. We will use a doll in that equation I showed you, so it's better. Also, I will use this repo in the next video, so better you check this and you download this. Okay. Also, this is the example I will use in my C++ site. I will use this example. What this is, simply the relation between, for example, let's think about a spring length and the force, and the coefficient of the spring calculated like that. The relation between length and force is like this, and these are unknowns. These are, for example, imagine you have a spring and you did many experiments and you get these data, so you need to find the coefficient of this spring. How you will find? You have many data, but you just have two unknown. So in this one, I will make the calculations, all of calculation in the C++ side. I will show that in the next video. But if I want to tell, for example, in this equation, let's little make it simplify in your mind. What is y here? Y in here is this one, which is this. Length is y. In here you can consider which is the result we know. And in the right side of the equation, which is force, and in this one there is no coefficient. In here I cannot show that actually. Maybe in the other video I will show that matrix maybe. Also beta, you already know this unknown, which is here. Okay, at least just consider this is y, this is beta. What is x? I will talk about it later. Simply in the next video I will make this example. I will find the coefficients y on C++ and I also visualize it. How to draw that line, I will show that. This is very simple. Least square really very simple and very useful. Maybe I couldn't explain this one, but really this is very useful. Any data, any experiment, you can use this equation. In many articles, in scientific articles, you can see that people still using this really much. And for example, image, my main video about is image processing. Even image processing you can use this much. How? Let's see, you have image classification and you are classifying car and the truck, let's say, and you have some data according to each of them parameters, and you are just distributing that data, and at the end you are getting this coefficient, this line, and when the new data came you can understand if close to this line it's maybe truck or car. You can also use in that one. Okay, this video I didn't assume this will be such long, but again it's long, sorry for that, and see you in the next videos then.